We have already seen some algebraic expressions and have even solved some algebraic equations with the proportions. Now we will formally define these topics. In algebra, we use a letter to designate a number that can change or vary. That is why we call it a variable. We do this so that we don't need to rewrite a relationship over and over for each specific case. The top one's not necessarily a formula, but you can think of it as a formula. It's actually called a function. The bottom one is a formula. Formulas, or functions as well, they work for infinitely many scenarios, and we can use the variables to show this. If we don't use variables, what we would end up having to do is prove every single time we want to use a relationship, we'd have to prove that it's true mathematically. In this case, we've proven these statements are true, and now we can use them as many times as we want for every situation we want. This top function here, this is called the prime counting function. It counts how many prime numbers are less than the number x that you plug in. You plug in x right into here, which ends up being plugged right into there, and there, and there, and right there. And so it'll actually tell you how many prime numbers are less than, I think, or equal to that number. So for instance, if I plugged in 10 into here, then from the prime numbers up to 10 is going to be 2, 3, 5, 7. So our function here would give us 4. That's this is a very long formula to do this, and you'd have to know calculus to use it. That's what the integral symbol there, right there, is for. That's calculus symbol. But we're not going to be handling that type of stuff. We're going to be looking more at these types of formulas here. This is rate times time equals distance. It's a very simple relationship, but very, very useful. And if we know what the rate is and the time that we travel at the rate, or for instance, if it's an hourly rate, the time that you worked for, then you can actually know the money or the distance that you've traveled by using that formula. To evaluate a formula, we need the values of the variables. So for instance, here if we know r and t, we can find d. But we need to know what r and t are, so like what the actual number value is. At this point in our math journey, we're just going to be given them. But typically in practice, you'd actually have to either measure it or derive it from some other formula that you have from other measurements that you've taken. We can rearrange formulas to find different things. For instance, if I wanted to solve for either rate or time, I can rearrange this formula by just dividing by the one I want. So if I want to know what time is, I'm going to divide it by rate, and that will give us time equals distance divided by rate. If I wanted to know what the rate is, I just divide by time, and that gives us the rate equals distance divided by time. These are all three the same relationship, but different formulas. And we'll talk more about that, how I'm doing that in 2 videos to come. To actually solve a formula equation, if you know what the variable you want, if it's already solved for it, in this case, let's say we wanted time here, we would use this formula right here. We would have to know what distance and time is. So let's say distance was like, I don't know, 200 miles, and the rate of travel was 60 miles per hour. To solve for time, all we have to do is plug in the numbers for the variables, 200 over 60, and then use PEMDAS to solve. In this case, it's quite simple because it's just division. But if it's a longer expression, we would use PEMDAS to actually solve it. You could say 10 over 3. This is going to be in hours since our rate's in hours. You could also say 3.33 repeating hours. All right, let's look at some formulas and some given values. So for this first one, we have 12 plus n, and we're solving it for when n equals 3. All we have to do is plug in n equal to 3 right here. Whenever you plug it in, you should put it in parentheses. It could interact with certain other things in the formula, which makes it easier to see when you put it in parentheses. In this case, they don't quite mean anything. There's just a number in there. So we could actually drop the parentheses here. We just have 12 plus 3, which is 15. All right, for s equal to 16, plug it right into there. We have 3 times 16. If they're right next to each other, like this case here, this is the same thing as saying 3 times s. It's just a faster way of writing it out mathematically speaking. We assume that numbers and variables that are right next to each other without anything written between them are multiplying. And it makes it so much faster to write the mathematics rather than having to write down the multiplication symbol every single time. 3 times 16 is 48. Here we have x equal to -7, and we have 2 locations of x. Both of them get changed to -7. So the first one is negative of x, which is -7, plus x, which is -7. So that came from -x plus x. Okay, the opposite of -7, that becomes a plus, and we get 7. A plus and a minus right next to each other becomes a minus. And so we get 7 minus 7, which gives us 0. For the next one, we have p cubed. Just plug in p equal to -2 right into here. In this case, it's very important that you write in parentheses the -2, because what you're seeing here is that -2 is being cubed. Not, if you didn't write parentheses, you would write -2 cubed. And this is saying 2 is being cubed, and you take the negative of it. This one here, the correct version, is saying -2 is being cubed. I hope you see that difference there. That's why it's important to put it in, whenever you're inputting things in for formulas or inputting things in for variables, always make sure you put it in parentheses. So -2 cubed is -2 times -2 times -2. 2 negatives cancel, and we have negative times a bunch of positives, which gives us a negative. And 2 times 2 times 2 is 8. You can also take this, one at a time if you want. That's fine as well. -2 times -2. Negative times negative is positive. 2 times 2 is 4. 4 times -2. Positive times negative is a negative. And 4 times 2 is 8. We get the same thing either way. Okay, m equal to 500. Plug it right on into there. We get 500 over 100. And simplify. 100 can go into 500 5 times. This one right here says q equals 47. Plug it right into there. We have 47 divided by 0. And anything divided by 0 cannot be found numerically. You actually say this is undefined. These are the type of things we have to concern ourselves in algebra, is because variables can be, whatever you want to plug into there. And some variables will end up giving you undefined quantities. In this case, the variable didn't give us, the problem gave us. It was q divided by 0, and that's always going to be undefined. But for instance, if I had something like 1 over x, I cannot put in x equal to 0. That is not allowed, because then I would have 1 over 0, and that's undefined. So we don't allow that. We don't allow x equal to 0. We would have to say x does not equal 0, and go on from there. That'll make more sense when you take like a college algebra class, algebra 2 class, things like that. Okay, here I have a few expressions here that we have given that x equals, let's see here, x equals -2 and y equals -3. We're just solving each one of these 8 expressions with the same idea that x equals -2 and y equals -3. So we have x minus y, x is -2, minus y of -3. You see that these become a plus, and we get -2 plus 3. -2 plus 3 is 1. Okay, now we have -2 times -3. Negative times negative is positive, and 2 times 3 is 6. Here we have -2 to the 4th power, let me write that in black, plus -3 to the 3rd power. -2 to the 4th is -2 times -2 times -2 times -2. All the negatives end up canceling because we've got pairs. 2 negatives cancel, 2 negatives cancel. We just have 2 times 2 times 2 times 2, which is 16. -3 times -3 times -3. 2 negatives cancel, meaning our answer is going to be negative. And we have 3 times 3 times 3, which is 27. Plus a minus becomes a minus. And 16 minus 27 is 11. All right, next one, and we have x, which is -2. I'm kind of write the rest of it here. The -2 in parentheses. The x on the bottom is also -2. And then the y's are -3. Okay. On top, we have a plus a -3, so that's going to be a -3. On bottom, we have minus a -2. That's going to be +2. -2 minus 3 is -5. -3 plus 2 is -1. And -5 over -1 is 5. I'm just using PEMDAS here. In all of these, I'm just using PEMDAS. You see, in the previous problem, I did x to the 4th first, then y cubed, and then I did the addition. That's because exponents come before addition and subtraction. The previous ones, they were all one statement, but here, x plus y and y minus x, you think of those as parentheses because of the fraction bar. And so we're doing those first. Once we are finished with those, which is just a number, now we can do the division. So this is really just PEMDAS that I'm doing here. Okay, for this next one, we have a bunch of multiplication happening, but we also have an exponent in there. X is being squared. So we have 2 times x squared times y. So first off in PEMDAS, we have to do the exponents. So -2 squared, -2 times -2 is +4. Two times 4 is 8. And 8 times -3 is -24. Okay, for this one, we have negative of x times y. Negative times negative is positive, so we have 2 times -3, and 2 times -3 is -6. You'll notice that this one is the negative of that one. We have +6 in that one, -6 in the current one that we just did. All right. Here we have 2, and then we have a -2 for x, -3 for y, and this whole thing is being squared. Now parentheses are first, right? And in PEMDAS, parentheses are first. We have to do the inside of this first. 2 times -2 is -4. -4 times -3 is +12. And 12 times 12 is 144. Okay. 4 over x, which is -2, plus y, which is -3, minus 1. Again, this is a fraction bar, so we do the top and the bottom in parentheses, and we solve those first. The top's already solved, it's just 4. The bottom is -2 plus a -3, plus a negative means minus. So we have -2, -3, minus 1. Gives us -2 minus 3 is -5. -5 minus 1 is -6. And we have positive divided by a negative, which gives us a negative, and 4 over 6. That can be reduced by 2 on top and bottom, giving us 2 over 3. -2/3 is our answer there. Okay, we just have a couple application problems. Find the power used in an electric light bulb. And this is the given thing here. I think I is typically given as capital I. I don't know why the book gave it as lowercase I. That's what I'm used to, is saying the current is capital I. And we're trying to find the power if I, which is the current, is 0.8 amperes or amps, and R is the resistance of the light bulb, which is in 150 ohms. Ohms is the unit for resistance. P, which is amps times ohms, well, amps squared times ohms, that ends up working out to be watts, which is the unit of power. Okay, to solve this, all we really have to do is take P equals I squared times R for when I equals 0.80 and R equals 150. You'll notice here that we have 2 significant digits here, and we have 2 significant digits here. So our answer should really be in 2 significant digits. 0.80 squared times 150. Using PEMDAS, we do exponents first. 0.8 squared is going to be 0.64. Pretty sure that's correct, but let me just check. Yep, 0.64. And we multiply this by 150. And we get 96. And this is going to be in watts. The unit for that is just capital W. All right, here's the next one. We have the total load T in pounds carried by a single floor joist is given by T equals WD, which is the dead load of the floor, plus WL, which is the live load. And this is multiplying D times L. D is the center to center distance between the joists, and L is the length of the floor. We're just trying to find T when these 4 units are given, which we need to know that. So WD is given to be 10 pounds per foot squared, plus WL is 40 pounds per foot squared. D is 2 feet. So we're going to have 2 there, 2.0. And L is 15. All right. We do parentheses first. The only thing inside there that we can do is 10 plus 40, which is 50. And I can really just drop the parentheses. I don't need to write them out. They don't quite mean anything at this point since they're just numbers inside of them. And now we do multiplication left to right. 50 times 2 is 100. 100 times 15 is 1500. And that is in pounds.